Hello everyone, welcome to the Math Bender. And in today's session, I'll discuss an alternate approach to solving trigonometric equations. We already have discussed the quadrant method where we figure out which quadrant the basic angle lie in and we solve it accordingly. But in this method, we'll see the graphical approach. I myself learned while teaching someone from some other board and I found it worth discussing. So let's start. Okay, so for example, I'll solve this question here. So I'll say that sine of x is equals to 3 over 4 by just solving it. Now let's sketch the curve from 0 to 360. So if I sketch sine of x, something like this, where this is 360, 180, and 0. Let's sketch another line y equals to 3 over 4. So it's going to lie somewhere here, roughly. Now, I can see that there are 2 points of intersection between the curve and the line, which is this and this. Both are positive. Here, we don't have to figure out or write down the quadrants because we can see that both of them are positive. So, since we know that sine of x is going to be 3 upon 4 and x is equals to sine inverse of 3 over 4. So finding the value, this gives you 48.6. So 48.6 is going to be, writing down somewhere here, first point of intersection. 48.6 is also here. So since it's symmetrical, so this much distance, this distance is as same as this distance. So what I do is I write x is equals to 48.6 and how much less is it from 180? So x is also equals to 180 minus 48.6. So this is going to be 131.4. So let's look at a different question this time. Tan x. Technically, the sketch of tan x is relatively everyone would want to avoid. So tan of x is equals to 2. Now, let's first step. This equation is pretty much straightforward. There is nothing to manipulate or send, but it's just that let's draw tan x from 0 to 360. Okay, so I've drawn it and the marking. So let's draw a line y equals to 2. So roughly, probably is going to be somewhere here. Now, this is the point of intersection when we equate tan x with 2, and this is the point of intersection. Let's mark them down. This is here and this point here. Now, since the function tan, sine, and cos, they are repetitive waves and they are symmetrical in every way. This is the concept that I'm going to apply here. So tan of x is equals to 2. So x is equals to tan inverse of 2. So checking the value of tan inverse of 2, which is going to be 63.4. So x is 63.4 from now. This value here until the point of intersection is 63.4. But what I would like to have is this value, this difference. So it's going to be 90 minus 63.4. And you can say it's 26.6. Now, this line and this part of the curve is as same as this line, this part of the curve, just that the degree is increasing. So can I say that this distance is as well 26.6? So if I subtract 26.6 from 270 degrees, I'll get the answer. So the first root is 63.4. The second is x is equals to 270 minus 26.6, which is going to be 243.4. So let's check the answers. So tan answer, I just don't want to write tan again and again. So I'm just plugging in answers. Instead of answer, I'll write first 63.4. So when I go up and I write tan answer, instead of the answer value, it's 63.4 is going to be calculating. So the value is 1.99. So now let's take the other value. So 243.4. Can you see the exact same answer? Both are correct. Let's look at another question here. Now here, if you see, there are multiple angles. I'll draw cos function here, and it is until 180 degrees. So this is what you need to keep in mind, and you need to be really good at sketching. So let's say if I draw this one, so 5 cos of 2x is equals to 4 till 180. I can say cos of 2x is 4 over 5, and let's sketch cos of 2x until 180 degrees. This is cos of 2x. This point here is 180. This point here halfway is 90. This is 45 and 135. Now, this graph is cos of 2x. Now, if I draw a line which is y equals to 4 over 5, so let's assume it's going to be somewhere lying here, and the distance, the points of intersection are these 2 points. Now, next step, find out the angle. So, cos of 2x is equals to 4 over 5. 2x is equals to cos inverse of 4 over 5. Gives me 38 point, so 2x is 36.87, and you divide that by 2. So it gives you x is equals to 18.4. Now, please look at this part. Since you know that from 0 degrees, this distance is 18.4. Now, from here, this distance, it has to be positive. Now, we need to know what this distance is going to be from, because this distance here is as same as this distance, because it's a symmetrical graph. So I can say that that distance is 45 minus 18.4, which gives you 26.6. So this distance is as well 26.6. Now, the angle is going to be, first in point of intersection is 18.4, the second intersection is 26.6 more than 135. So this is going to be 161.6. Okay, so let's look at another question. Let's see if the same thing is up till 360 degrees. For a moment, let's try to visualize that. And we have a question like this. So 2 minus 3 sine of 2x is equals to 0, or 3 sine 2x is equals to 2, and sine of 2x is equals to 2 over 3. So first step, let's draw the angle, the sketch of sine 2x until 360. So that's the first wave, and this one is the second wave until 360. So I'll mark it. This is 360. Half of it is 180. This one is 90. It's 270. Now, draw the line y equals to 2 upon 3. Let's assume it's going to be somewhere here. As you could see, there are 4 solutions. 1, 2, 3, and 4. These are the points of intersections. Now, since we know that sine of 2x is equals to 2 over 3, and 2x is going to be sine inverse of 2 over 3. So 2x is 41.8, and you divide that by 2. So it gives you x is equals to 20.9. Now, 20.9 is the difference from starting point, this 20.9. Since the sine wave is symmetrical, then this distance is also 20.9. This distance from all these, so this is as well 20.9. So as this distance. So let's write down all the values that I see. So x is equals to, first one is 20.9. Second, as you see that the next point of intersection is 20.9 degrees before it had reached 90 degree. So which means 20.9 degree less than 90. So x is equals to 90 minus 20.9. We'll check all the answers. So 69.1. X is equals to, now next one, as you could see, the next point of intersection, the third point of intersection, is 20.9 ahead of 180. So I can say 180 plus 20.9, and x is equals to 200.9. And the last one, as you could see, same thing, 20.9, the fourth point is 20.9 before it had reached 270. So I can write this as x is equals to 270 minus 20.9. 249.1. Now these are the 4 values that we got. within the domain. So let's check all the values. So since the function is sine 2x, what I'll do is sine 2, and I'll just write answer here, which means that whichever value that I'm going to plug in will automatically be the same. So the first one was 20.9, and the function was sine 2x. So sine 2 times answer gives you 0.66666. So the second value was 69.1. And if I plug in the same, can you see you get the same answer? The third value was 200.9. And now if I plug in the same as answer, gives you the same value again. And the last one is 249.1. Plugging in sine 2 times answer gives you the same. So no matter, as long as you're good at sketching the curve, this is one innovative way that I've found are really interesting to share. Then again, it's up to you to decide whether which method you would want, you're comfortable solving with. But this was something that I felt like I should share with you guys. Until my next lecture, I'll discuss more on complex angles. Till then, take care. Bye bye.